Okay, now let's look at A star algorithm. So this is an advanced version of the Dijkstra's theorem algorithm. The basic concept is the same. The only difference is that we add a heuristic value, which is a kind of a smart guess, along with our cost, which is G, the movement cost. Now, when we have a graph, we are going to look at heuristic value of to reach to a node, its movement cost, and it will be represented by Fn equal to Hn plus Gn. G is the cost of movement cost uh, from one node to the other node. Basically, A star algorithm adds the direction as well into our calculation to find the shortest path. We gave the example of Dijkstra's theorem in the Dijkstra algorithm about the Google Maps, that whenever you need to reach from from your starting point to the destination, it gives you multiple paths that you can follow along with the time to reach to those paths. Now these paths will have can have different values at different timing, different time reaching time, and different times of the day. For example, if it is 5 p.m., so we know that 5 p.m. is the rush hour. There will be lots of traffic. There might be some collisions on the road. So basically, Google Maps always tell you the best path to go through. It might not be the shortest path according to the distance. In Dijkstra's, we are just following the distance or the movement cost. But in A star algorithm, we are giving a smart guess as well, using trial and error. Like for example, when you reach to a point, then you see what's the next possible path. And also, when you're using Google Maps, it could be like you didn't go to a specific road, like instead of right you move to left, and like that. So it recalculates the route. So it is using the A star algorithm to give you the best possible shortest path to reach to your destination. Now we'll be looking at an example from the paper to help you to. Let me erase all of this. Now again, in your syllabus, I'm going to mention you will be given a graph using which you have to find the shortest path. Now in your book, in Hodder and in Cambridge there is nothing specific about it. They just mentioned the algorithm. But in the Hodder book, they have a matrix or a grid to show you how to calculate, how to go through, how to use the algorithm to calculate the shortest path to reach from a starting point to the end point. Now that is a more general view, that is a more general method that is used in AI, in machine learning. But for the case of our algorithm, let's just focus on the graphs for now. This is a relatively new part of the syllabus, and only in 9618 this was added. And there have been only 2 questions up till now. So we'll be focusing on those questions to help you to understand the A star algorithm. Now when you see the graph to it, you know that these are our nodes or the vertices, and the line between them is the edge. We already know about G. G is the movement cost from going from one node to the other node. But now we have another value added, which is H, or the heuristic value that we need to take into account when we are calculating the shortest path. Now this question is going to have a table. As you can see, we have the starting node, destination node, cost from the starting node, and the heuristic value of that specific node that we are talking about, and then we'll calculate the total, and according to this we are going to follow the path that gives us the least value. Now the first two rows are already done. We have the beginning node, begin over here, and as you can see, we'll follow the same kind of algorithm that we used in Digestra. We have to go from node to node. We are going to look at all the nodes connected to a specific node, and we are going to see that which have been processed. Now in this case, because we are not looking at all the nodes, we need to reach from beginning to the end over here. Although we can see that this is, manually, when we look at a paper map, that we can see that this is the best path. But let's see if it is the best path or not, or if there is any other path that will be better for this. So you can have something like this, and we can keep on highlighting the path that we have followed, because you have to mention the path at the end over here. Now starting node is begin. From begin to begin, this will always be the first row. The cost is 0 and the heuristic value is 12. As you can see, we have the heuristic value 12. So f becomes g plus h, 0 plus 12 equal to 12 over here. Then we have begin to a. That means from our connected nodes are A, B, C and D. We have to look at all of these nodes. So A, B, C and D. So from begin to B, then begin to C and begin to D. Now begin to B is 6 and the heuristic value is 7. So we have the cost as 6 and the heuristic value as 7, and then 6 plus 7 is 13. For C we have 5 and 7. So G is 5 and heuristic is 7. Our cost, our total F becomes, total function cost becomes 12. Then 4 and heuristic is H is 11. So we have from begin to D 4 and 11, which becomes 15. Now from beginning we have these 4 paths that we can go. Now out of these paths we can see that begin to C is the one that is most that has the least amount of H, least number of H. So we are going to go from B to C. Now from C, let's see which nodes are connected to C. To go forward, C to G, we have only one node. Going forward, we look at G, and it has the G value of cost of 2 and heuristic value is 5. Now in the cost, we add up to the cost starting from the beginning. We have B to C 5 plus, what was it, 2 equal to 7, and the heuristic value is 5, not 4. So 7 plus 5 becomes 12. Now there is only one node, so we are going to follow the available single path. Now from G we have to reach the end. To end we have a single path from G to end, or we can go from G to F as well. Now we can say that we could go because it is connected to this, but you can see that D is like going away from the end point, so we're not going to consider that. So G to end and G to F. So we have G to N and G to F. Now G to N has the value uh, 7. Now this 7 from C to G, this was 5 plus 2. So we need to add 5 plus 2 to it, starting from the beginning to C 5, then C to G 5 plus 2, then G 2 and 5 plus 2 plus 7. So that becomes 14. The heuristic value of end is 0, so we get 14 value. Now G to F is 4, which means 5 plus 2 plus 4 becomes 11, and the heuristic value is 1. So we were going from G to F. The G value is 4 and the heuristic value is 1. Now in this 4 we are going to add all the previous G's as well. So G 5 plus 2 plus 4 is 11 and the heuristic value is 1. So 11 plus 1 gives us 12. Now from G we have two paths, to N and to F, but still you can see we have the lesser value 12. So we are going to follow G to F. Okay. G to F, the picture moved, I think. Okay. So we have now from F, we can see that we have to move from F to end. F, that is G is 1 and has the heuristic value 0 if it is not mentioned, and it is going to be 0. F to end, so 5 plus 2 plus 4 plus 1 gives us 12, 0. So total at the end we have the value 12. So begin to C 5, C to G 7 or 5 plus 2, then G to F 5 plus 2 plus 4, and then we add 5 plus 2 plus 4 plus 1. So our path becomes begin to C, G, F, and then end. Begin to C, to G, to F, and end. So this is how you solve the A star algorithm. You keep adding the N and the H values. The H values only added for the current node, and the G value is added from the start node. At the end you should get the final shortest path,